So we imported some modules the last time, and we want to answer these two questions. How did the programmers of the math module do it? And if we wanted to write our own modules, how do we do that? And to be able to do that, we need to have knowledge in indexing and slicing, and we also need to have some knowledge about list functions, ranges, and for loops. We start by discussing what indexing is. Indexing is just accessing the elements of any list. Um, the index of the members in the list starts from 0. So here we have a list here H, and say that we want to access the first element in this list. All you have to do is start by calling the name of the list, followed by a square bracket. Then you pass the index of the value, and I said the elements are indexed starting from 0. So the first element here, which is 1000, you index it by passing 0, and when you run that, you get the value. So if you wanted to get the last element in this list, all you have to do is to know the number of elements in the list, and you can access that. So if this is 0, 1, 2, 3, 4, 5, 6, 7, 8, and 9. So if you do that, you will get the last value. Please, I hope this is clear. Is this clear? Alright. So the indexing is also done from right to left. So if we wanted to index the elements starting from the back, we can use negative numbers. So if I wanted to index the 5500, is in the index of -1. So this will be -1, this will be -2, this will be -3. This is you indexing from the right to the left. So if I did that, I'll get the same value as we had using the indexing from the left to the right. Okay. Now the next thing to talk about is mutations. So there is something that is said in Python that you normally hear something lists are mutable. If you've not heard of it before, what it means is that we can change any part of a list after it has been created. So suppose we wanted to change the first value in this list to some number. This is what we do. We'll call the name of the list followed by the index whose value we want to update, and then we'll set that to a different value. So if you print that, you see that the list will be updated with the new value that we've inputted. So with your knowledge of indexing, you can update a particular list after it has been created using the statement here. So that is all about indexing. If you have any question, please let me know. So we move on to slicing. Um, Slicing uh, is an upgrade of what indexing is. Indexing accesses individual elements of the list. What slicing does is that you can access more than one element of the list. So supposing we wanted to access the first four elements of this list. So we want to take out 45,500, 2,000, and 2,500. What you do is, again, the name of the list followed by square brackets. Then you pass the starting index of the list, or where you want the slicing to start from. So I want to start from 0 to the last part of the range or the slice, which is the 2,500, which is as the index of 3. This is 0, 1, 2, 3. Okay, so what this means is we wanted to include 2,500, but you see that it only ends at um, the 2,000. This is one thing about Palantir. The last value that you input is exclusive, so it's not part of it. So you always have to add one to the slicing range. So if you wanted the slice to end at index 3, you always have to include the fourth index, which will be exclusive. So when we do that, we will have uh, the first four values of the list. So that's what we call slicing. So with slicing using positive numbers, so from left to right, you could do the same thing using negative values as well. So you could say negative 11 to negative 5. I think I don't want to count, so this should be supposed to be negative 6. Yeah. So when you do this, so this is indexing the from the left. So when you do that, this is what we get. These are pretty easy things to do, so they are not really heavy, but they are um, preliminary skills you need to have to be able to do the next session. Now, slicing has a third input. So you input the first value of the slice, then the ending index of the slice. There's a third um, argument you can give to slicing. So suppose we wanted to take values at odd indices. So 45, 2,000, 3,000, 4,000, and so on. So values at odd indices, those so 0, 2, um, 4, 6, 8. I'm saying odd, I should rather say even indices. How do we do that? You can So let me expand the entire list. So I'm going from the first value all the way to the last one. So I think it's 11. Let me run that first to see. Yeah, so this is the entire list. Now you can add a third argument that we call a step. So you can add a step of 2, and what that will do is it is going to skip over all the odd indices. So we start from 45. So with a step of 2, it will now append 2,000, then 3,000, 4,000, 5,000. And so this is what we have here. So the step value can be anything. So by default, the step is 1. So if you put 1, you just get the same thing that you have. So if you increase the step to 2, then you have all the indices at step 2 from the first value. Okay. So we just talked about indices, slicing. So we just finished these two requirements. And one thing before we move on to list functions is list concatenation. Concatenation is just a fancy word for joining. So supposing we wanted to join um, this,
Please, I have a question on slicing.
yes, please ask.
I was trying to use the negative index,
Yeah,
which is starting from -1 to from counting from your right to your left.
yeah.
And then when I was doing the slicing with the negative index, I realized that I was trying to the H part. I was trying to slice from -5
Mm-hmm.
from -5 to -5 to the end, which
So,
is
so this is
uh,
-1, this is negative 2, 3, 4, 5. So from here all the way to the end.
no, from here to the end. You're
Oh, okay. So
on your
from here
right.
to let's say so negative. This is going to be so -1, -2, -3, -4, -5, -6, -7, -8, -9, -10. So from negative 10 all the way to probably here.
No, I was trying to I was trying to do from -1 to -5.
Okay.
But I realized that you said if you are trying to do the slicing, you have to take like um an index that is greater than the range that we want.
Yes.
And then when I was using the negative, I'm not supposed to bring the -1, right? Because if I bring the -1, it won't like print the 5,500 in my list.
So like um negative
Like
5,
negative, yes,
5 to negative 1, like this.
yes. And the step is two,
Okay. Yeah. So yes. So if you add 1 to negative 1, what do you get?
-2,
No, no, no. If you add 1 to negative 1,
0.
yes. So
I tried using it. It gave me an empty list.
yeah. So I was getting there. Because you are using negative indices, 0 is not part of the indices. So that's why we started from negative 1. So actually, what you do is you don't put anything there. So this is you telling Python that you are indexing all the way to the end. So if you
Okay.
don't put anything there, you will get the value that you want.
Wow. So what if I'm trying to add an argument that it should be even number?
Yeah. So you just again you just do the same. You just leave there blank, followed by the next column. Then you put the even number step there, and it will
All
do
right.
the
Thank you
same
very
thing.
much.
Yeah.
All right. Thank you very much.
Yeah. Thank you. So that was a good question. But if you are not if you don't like the negative index, nothing should stop you from using the positive ones. But that was a good question. All right. Um, where was I? Yeah, concatenation. So let me create the next. We only have one list right now. So let me create the k, the list for the k. So, so we want to join. What joining is I'm going to show you now. So if you want to join two lists together, use the plus sign. If you remember from the previous lecture or session, if you add two lists, it doesn't mean that it's going to add the individual elements. What it will do is it's going to join them. So if you run this, you'll see that the first values are for age, then followed by the values of key. So that is what concatenation is. If you want to concatenate two lists, you use the plus operator. This is one of um, not widely used operations. I'm putting it here so that you see that you can do some operations using the normal um, mathematical operations that we have, but this only joins the list together. All right, so the next thing we need to understand is list
Yeah.
functions.
Please, please, I also have a question on that one.
Please ask.
All right. I realized that when we joined it with a plus sign
Mm,
and then we just coded H plus K, we
yeah,
had like a vertical order of the combined list.
yeah,
But the moment I used the branch function,
yeah,
it was given in an horizontal um,
yeah,
output.
yeah.
Yeah.
It's the same thing. It's just Colab printing the values in two different ways. It's the
Oh,
same
okay.
thing.
Okay.
Yeah.
Yes, please.
Okay. Thank you. Right. Please again, don't apologize for asking questions. You can ask any question at all. Your questions are helping people, so don't be apologetic about it. All right. So the list functions. So these are functions that can modify the list in many ways. So there are different functions for different modifications. And you can find most of these functions on this site. I've linked it, and you can go to it if in case you want to understand most of these lists yourself. So there are a lot, and you don't really need all of them. We are going to talk about the most widely used ones. But if you need any list for a particular task, you can come here and then use the search, and then just describe what you are looking for, and it will return probably one for you. Okay. So we start with the first one. It's called the append. So usually most of the time you have a list, but you've already created a list, but you like to append or add some value to the list. So like the name suggests, it's append. So you can append a value to a list that has already been created by using the append keyword. So if you look on the side, you see that all the functions are listed with list dot list dot. So you have to start with the name of the list, followed by a dot, then followed by the name of the function you want to use. So suppose we wanted to append a value of, let's say, 550 to the k list. You do that by calling k dot append followed by the value you want to do. Then you can print k, and you see that the value 550 has been appended. One thing to note is that the append function only appends the value at the end of the list, nowhere else at the end. If you want to insert the value as a particular index, there's a function for that, and you can look for it, and it's already even here. That's the insert keyword, so you can go and um, do that on your own time. Another important function is the count function. This returns the number of times a particular value is in a list. So suppose we wanted to know the number of times, let's say 450 has appeared inside this list, and we don't know. You can call the name of the list followed by count, then followed by the value that you want to know its count of. So the 450, and we will see that it's once because the 450 only appeared once in the list. Again, there are other functions that you can go and look at, but we can't go through all of it, so we'll stop there. Now, there are some functions we call global functions. So meaning you don't have to do any list dots before you can use them. You can just call the function direct, like how you can call a print function, and you can use them. And I think there are 5. I only placed 4 here because those are the ones that we usually use. So the first one is the length function. And if you want to know more about the global functions, you can use the link here. So as you can read on your screen, what the length function does is it gives us the number of elements in the list without us counting. Again, you realize that when we were trying to find the index, we were counting some values. So if you wanted to know the number of elements in the list, you can use the length function. So you can use the length and find the number of values in k, and we say that it's 11. We can also use that to find the number of values in the concatenation of k and h, and then it will give us the value of 21. So that's what the length function does. We have the max function, which gives us the maximum in a particular list, and we also have the minimum, which does the same thing. And there is one function here that we will need, which is the sum. So we can find the sum of a list calling the sum function. So this is it. So if you add all the values in h, where is h? Here. If you add all the values in h, the total is what we have here. So you see that right from the start, now we can even calculate um, the denominator of this equation just using the sum. So now we know how to calculate the denominator of this equation without importing any module. The next part is how to figure out what the numerator is going to be, and by by the fifth session, we're able to do that. All right, so we've tackled indexing, slicing, we've tackled list functions. Now we'll talk about ranges and for loops.
Please, I wanted to ask a question on the append.
Okay.
With the append, can you append concat, a concatenated list?
I know
Like
it's a mouthful. Just say a joint list so that you will not.
a
Yeah,
joint list.
yeah,
Can you append like a value to a joint list?
yes. So let's say let me create a new cell here. So this is, let's say, let me just call it an HK. HK, yeah. So HK is the concatenation of H and K. And so now HK, I want to append a value. So let me see. First of all, let's just print what HK looks like. And then I can append HK dot append let me see 1000 or something. Then
Yes.
I can print HK again. Then we see the changes. Yeah. So the first one is the concatenation. So that's what the line 2 is giving us.
Yes,
And
please.
after we've appended the 1000, that's what we have. Now,
Yes.
I've forgotten to tell you guys something. So you see that when I'm writing codes and it starts to get long, I have the lines numbered. So from 1 to 4, depending on how long it is. If you want
Mm,
to get this, because it helps when you are debugging. If I say debugging, it means if you get an error, usually the interpreter gives you the line at which the error occurs. So because your line is not visible, it might be difficult for you to debug your code. To make the line show, you click on the cog icon here or the settings icon here, and you go to the editor. So we are going to how do you call it? Change some settings in the editor. So usually I just check all the marks here. But for the line numbers, if this is off, you can check it to let the line numbers show. If you do all that, then you can save it. You can play with the other options to see how your um, interface will look like.
yes, please. Font.
All right. So yeah, yeah, good. Again, you don't only have to append a value. You can also append an entire list to another list. So you can try that out as well. So you can append another list to um, already existing list, and you see that that list has been appended here.
Mm, yes, please.
Okay. All right. So now the range function is one of those global functions that we are talking about. So we just talked about for, and another one is the range function. The range function, if you don't understand any of the functions here, the range function should be one that you should get. So the range function, what it does is, I'm not going to read all of this. I'm just going to show you what it does. So previously we were creating lists by writing them out ourselves. So here I was going to write h is equal to then I'll paste all of this. If there were thousands of them, I would have written this by myself. But if your list is progressive or it's an arithmetic progression, meaning um, it follows a particular pattern. So the first value here, we added 500 for it to get a second value and so on. So the difference is just 500. You can generate this list using the range function. So this is how you do it. So you call the range function followed by the first value of the list, followed by the last value of the list, then followed by the step. The step is the difference. In our case, the difference is 500. So when you do this, you will get um, a list that has been generated. But in order to see um, the list, already you have an object. So this is a range object, but we want to see the values ourselves, or the values in this range object. So what you do is to pass the range object inside a list object. So I'm going to cut this and put it in between a list function. So if I do that, I will get the values listed out. You should only do this if you want to see the values. The range object already creates the list internally, but you can pass the range object inside a list function if you want to inspect the list. This is useful because right now you can see that the 550 has not been included in the list. This is because, like I said, the last values in Python always is excluded. So because our difference here is 500, we have to add that to the list so that the 6,000 will be exclusive. So we update the range, and then if we run that again, we will have the values from 1000 to 1500. So this is how I'll create the age and the key from now on. So with that, I can create the key also in the same manner. So if I print k, I should have 50 all the way to 500. So whenever you have a list which is in progression, it has an ending and then it has a consistent difference. You use the range function to do that. So like I said, if you have a grasp understanding of how the range works, you can do away with the list. You don't have to bring the list. But if you are just starting, the inclusion of the list function will not change anything. It just add more to the code. So subsequently, when I'm moving, you see that I'll be using range and I'll not be including the list. Okay. I'll stop here and ask if you understand the range. It's very important that you get this because this is needed. It's really needed. Okay. So if you understand it, then we can.
Please, a quick one. So does it mean that we only use the range once we have a list that progresses, or like that is in a certain order or has a certain step?
Yeah. For me, if you have a list that is in a certain order, you don't have to list it yourself. I think you should use the range, but it's up to you. If the list you have is 1,000 and you think you can code it yourself by typing this manually, that's that's up to you. But please, it is termed as a best practice when you use the range. It's better to use the range.
And I think it's better because for data analysis we have like large data sets that you need to work with, and most of them have a common difference.
Yes, yes,
That step. So
yes,
maybe it's just a difference of 20 or 10 or 100 or 150.
yeah, yeah,
You can just use the range to do that.
yeah. Okay. So this is the second way of creating a list. So first, we can create lists manually by using the square brackets and listing them manually. The second way is if you can recognize that the list you are trying to create is in a certain order or is progressive. You can use the range. Another way of creating this list is what we call list comprehension. So, what is list comprehension? Supposing I wanted to create these same k values that I've created, I'll create it using list comprehension, and this is list comprehension.
Please, I have a question.
Yes.
So, had it not been that we had called the range function, and let's say we used the list without the square brackets, we're going to, let's say we are going to print h, we're going to have an error.
So you mean I should take off the range like this?
Yes.
Yes, you get an error.
Wow.
The list function here, it only converts what we call an I trouble. An I trouble is an object. So an example of an I trouble is the range function that we just looked at. So it converts the internally generated list to an external one that we can see. So if you are passing individual integers into the list, how do you call it? Into the list. Let's print it and see. Yeah. So as you can see here, it says it's expecting just one argument, and then we gave it three. Like I was saying, it only expects one argument or one I trouble. It needs to have one I trouble for it to be converted into an external list. So if you call the list function, you are passing individual elements into it, it will not generate the list for you. If you want to manually create the list, always use the square brackets. Is that fine?
Yes. It is.
Okay. What's wrong with my system today? Oh, yeah, I understand now. I don't know what's happening with the internet today. Alright, it will probably run on its time. Okay, so I was I need this to run. Let me restart the page. But can you guys hear me clearly? So why? What's wrong?
Yes, please. I think the error is indicating the H list that we did.
Yeah, yeah. So I corrected it. I'm trying to run it, but it's still stuck. Come
I think when you run it, you still get the list that you defined.
Yes, yes. I was trying to. Yes, I was trying to show that, and I don't know why it's still lagging. Let me run. Let me
But
stop it. Let me just restart the kernel. Let's see.
yes, please.
Okay, yeah, it's back. Right. So this was what I was trying to say. So if you want to create the list manually, you do this. But we are not creating this. We are trying to create a list from 1,000 to 5,500. So we update that. But Peggy, I hope the your question has been answered.
Yes, please.
Okay. So I was saying that the next way of creating a list is using what we call list comprehension. So suppose I wanted to create the same key that we created. Let me print the key. With list comprehension, this is what you do. So I will explain what all of this means. Okay. Okay. So list comprehension. To create a list, the reason why this list comprehension is really needed is will be seen when we are trying to solve this question here. So we are creating the same list using the range function, but what we call list comprehension. So the statement is always the same. So it's like a template that you just have to edit. So the variable followed by for, followed by the variable in, then followed by your range. It's just a template that you can edit. So the variable that you are going to print for the variable in the range that you are trying to go over. So what this means is that it's like English. So for each of the variable in this range, print that variable. That's what the list comprehension is saying. For every x in the range, print x. So that is what this list comprehension is saying. So for every x in the range that you specify, just output the x. So that's what it means. So x for every x in the range 550 to 550, print x. So it will go over all the elements in the range and then just input them out. So the first element in this range is 50, so you see that 50 has been printed. The next element is 100, so it will just go over all of the values. The reason why this is powerful is supposing we wanted to find the square of each of the values in this range. All you have to do is just square the variable x. So we are saying that for every x in this range, or for every element in this range, print the square of the elements. So if we print that, you see that all the values in h has been squared. That is why list comprehension is very important. With list comprehension, you can achieve a whole lot. I have just introduced something. So this is what we call a comment. If I write any code and then I append or I precede the code with a hash symbol, Python will just ignore that particular line. So this particular line is not for Python, it's for you and me to read. So if you write any code and you append a hash symbol to it, Python will see it as a comment or basically a text and just skip over the lines with the hash attached to them and continue to the next line. So I'm not writing these first two lines for Python to run. I'm just writing it for you to explain something to you. So this is what we call a comment. You'll be seeing more as we move on. Is the um, list comprehension clear? So like I said, it's just like a template. And one thing you should know is that the x variable can be any letter on your keyboard. It doesn't have to be x. It can be anything on your keyboard. Just know that when you're referencing it, make sure you're using the name that you used in the for loop. So this is the part of the list comprehension that we call the for loop. So for every I in this range, print I. For every x in this range, print x. So just make sure that if you are using a particular variable, you reference the same variable as is in the for loop. Okay, so with this knowledge, we can now um, evaluate something like this. If this is your first time seeing this symbol or you don't really understand what this is, what this means is with the expression in the bracket, we will substitute the value for n starting from 2 all the way to 4. So we will have something like 2 times 1, sorry, times 2 plus 3, then followed by 2 times 3 raised to the power 2. So basically that. So we are just substituting the value for n from 2 all the way to 4. So we can do this by using um, the list comprehension that we have. So in range of 2 to 4. So we have to 5 so that 4 will be included. So if we run that, this is the values that we'll have. So when n is equal to 2, we'll have 11. When n is equal to 3, we'll have 21. When n is equal to 4, we'll have 35. So after finding this list, we need to find the sum. That is what the symbol that looks like an M will do. So we need to find the sum of this list. And if you remember, we have a global function that can find the sum. So all you have to do is to call the sum, and we run that, and then we'll have the value. Is that okay? We have at least 5 minutes more. Is this okay? Sorry about the noise earlier. Are you guys still there?
Yes, please. We are here.
Okay. So this is the list comprehension that we are talking about. So now you've learned all the things you need to know about um, creating modules. So now you have the skills. So in the next session, which is on Tuesday, you will be introduced to creating your own modules. So you will see that one function that we will need is the product function. So for example, if we have a list, say we have a list, and then we want to find the product of the elements of this list, we have the function to find the sum, but we don't have the function to find product. And if you look, if you check through all the functions that are available, or even the global functions, there is no function for finding product. So in the next session, we'll create our own module and add a product function to it. That can find the product of a list. So that will be it for today. Any question? And in the course of the week, I'll be sending an exercise like I've sent, so for you guys to try your hands. Okay, I'll be sharing the fifth one. Please, the fifth section, if I send it, please, if you don't understand anything, don't panic. I'm sure most the other ones that are saying they were easy for you guys to understand. So if I send this one and you don't get anything, just let me know and I'll help you out. Okay, see you guys on. Is there a problem?
So you are scaring us. You are scaring us.
No, I'm not scaring you. I'm just saying that it's quite involving compared to the other ones. So if in case it's too much for you, don't worry. I'll, I'm always here to help you guys out.
Yes, please. Thank you very much.
Okay, so thank you guys for joining. I'll see you guys on Tuesday next week. Bye.
Bye.
Hey, but this starter cohort there is more than advanced though. Anna,
Are you
be
sure?
prepared.
That's why I'm asking if the things are because I think it's rather um slow and I'm introducing the things bit by bit, but I don't think it's advanced. It's the second cohort that will be a bit advanced.
Okay. But at least we are making progress, so it's
Yeah.
fine.
Okay. So we've spent all our time. So see you guys next week.
Yes, please. Thank you very much.
Yeah.